All right, guys, welcome to Mr. Schultz's class as we find roots and simplify them. So, I'll be able to simplify roots of expressions with radicals. So, let's go over this. Remember that the index is the number above this radical sign. We're going to be dealing with the radicand right here. Basically, we're going to take this information, we're going to do something to this radicand, simplify it. So if I have this right here, I understand that I have a square right here. I'm going to find both the positive and negative answer to this. So if I simplify this, I understand that, hey, this is going to be positive or negative. I understand I have the square root. I can change this 25x squared. So 25x to the fourth will equal 5x squared. I know this. So I can rewrite this like this right here. 5x squared squared. And these two things right here will cancel out. So I'm left with positive or negative 5x squared. So I could put in an answer like it'd be both positive or negative. That's good. Okay, next up. I see this right here. I see y squared plus 7, and then all of this to the 12th power right here. So what I could do is I could use the power rule right here and understand that, hey, look, I want the negative answer, and I'm going to rewrite it right now. So rewriting it, this would be 6 times 2 is 12. I see this right here, and squaring and square rooting cancels out. And so what I'd be left with, y squared plus 7 to the 6th power. But wait, I wanted the negative of it. Now this last part right here, I have 343a to the 18th and b to the 6th power. Okay, hold up everybody. I'm going to try to do it so that I can cancel out. I have this cube, and I want to have a cube so I can cancel them out. So, hold up. All right, it feels kind of like cheating, but 7 times 7 times 7 is 343. 8 to the 6 times 3 would be 8 to 18. The b squared to the 3rd power would be b to the 6th. So, knowing this, I can cancel out this cube root and this cubed, and I get 7a to the 6th and b squared. Here we go. Now, hold up a second. We're going to do one more. Let's simplify this imaginary number. And why do I say it's imaginary? Because I can't simplify negative 289. So I know that what I'm going to do is I'm going to pull out the negative, and then I'm going to have the square root of 289, and I'm going to have to simplify that. So let's pause it. So each one of these I can simplify. The square root of negative 1 will give me I right here. The square root of 289 would give me 17. So I'm going to write 17, and I'm going to put this I right here. So I know it's 17I. Now, the square root of c to the 8th would be c to the 4th. And finally, the square root of d to the 4th would be d squared right here. D squared. So this is like an imaginary number right here because, hey, look, you can't find the square root of a negative number, but we can just write it out, and now we have. So let's continue. So there is a little problem though. So if we find an even root of an even power, and the result is an odd power, we're going to have to use the absolute value of the result to ensure the answer is non-negative. So we can't put a negative answer in there. We want to make sure that it's non-negative. So let's show some examples. So let's find the absolute, or let's find the simplify both of these expressions. So I know that 81 would be like the fourth root of 81, and 8x to the fourth would be 3x. But we can't just leave it like that. We have to say, hey, this is an even root, and it has an even answer, even power right here. So we have to say, hey, look, it's going to be absolute value of that. So our answer, our root right here is going to be 3x right there with an absolute value, 3 times the absolute value of x. So no matter if we put a positive or negative, it's going to make it positive. So what if we do the next one to the 8th power? So what might be helpful is if we separate it. We say, hey, we have 256 to the 8th power, and then we have this 8th power of this expression right here, y squared minus 2 to the 24th. So let's see. So we get 2 times y squared minus 2 to the 3rd power. But wait, this could give us a negative answer. So if it was like negative 2 times negative 2 times negative 2 would be a negative answer. So what we're going to want to do is we're going to want to put absolute value right here. So since this could be negative, we have to ensure the principal square root is non-negative. All right, let's pause it. Now this might be one of those questions you might have. So what are 2 questions that you might have about this lesson? I know one of them possibly has to deal with that absolute value we just covered. But no matter what, I'll see you guys in class. I hope you have a wonderful day. Bye.